In this video, we are going to be looking at how to get the median absolute deviation. And we're going to be doing this in TSQL. Now, if you are using Python, if you're using R, or you're using Oracle, I believe that all of those languages, you do not need to go through this whole process. So one of the advantages of using a more math-oriented language, TSQL is not one, or .NET is not one either, is that you don't actually have to go through this whole thing. So that's really cool. But I could be wrong, and if there's been a change to any of those languages, you might want to check that out. However, we're going to be going through the logic of some of this. Some of this is going to require that you're familiar with statistics, because I'm not going to explain like normal distribution, but you can look that up and go from there. So last week we talked about outliers in a data set and how they can impact it, and we might want to remove outliers in a data set. It's very rare that outliers or extreme values impact median, but every now and then it is good to look at a data set where we do look at those extreme values removed. So the first thing that we're going to do is we're going to look at a data set with 11 values here, and we see that we have mostly values 1 and 2, and we have one value that's 30. And we also see a couple of things, which is the median value is going to be this value right here, which is 2 in this data set. But if we removed 30, the median value would actually be, TSQL is going to come back with 1, but the median value would actually be an average of the two middle values, which would be this. So it'd be 1.5, but 1 will suffice for this example. So that is something that we'll observe in this data set. So this outlier here, and this would be an outlier in an average sense, but this outlier here is having an impact on the data set in terms of even median. And I'll discuss an example, a real-world example of where this applies. So the first thing that we're going to do in order to calculate this value here is we want to get the median value. So again, I'm not going to go over too much of this, but what we're essentially doing is we're ordering the data here, and we're doing a division, and we're getting median, and we're setting this middle count here equal to median, and we're saving this in this variable median. Now this is just the original median, so that's one thing to remember. So this would return 2, and we'll see this in a second. When this outputs, it will say the original median value, which is going to be 2, and that's because the latter value is going to be 1. Okay, so that's step 1, is to get the median value, and we get the median value. Keep in mind there are other ways in TSQL to get the median value. This is just one way to do it. The next thing that we want to do, step 2, is we want to get the absolute value of the subtracted median value from each value. I realize that sounds a little confusing, so let's go back up to this. So we have this median value here that we're setting it here. I'm declaring this table, which is the values. This table is going to include all of the values here. So all of these values are going to be in here, except each of these values, as we see, are going to subtract the median, right? So it's going to be 1 minus the median, which in this case is 2, 1 minus 1 minus, but we're getting the absolute value, right? Oops, highlighted the wrong thing here. So we're getting this absolute value of this. So there's not going to be no negative numbers, okay? So once we do that, we're going to insert this into the variable table. And once we're done with that, then we're going to get the new median from the absolute value of subtraction median values from each value, okay? So now we're going to get the median value of this table right here. So now we want to get the median value of this variable table. And so if we look at that, we get the median, and we'll see, and this is where having a little bit of knowledge of statistics is going to be what determines that. We get this median value here, and we're setting it to the I call the MAD median. This is this a median deviation, if you would. That's what it stands for, median absolute deviation. That's MAD, okay? And I'm setting that to equal to the val. So this is where, again, this middle count equals the median. So we're getting that median value, right? Now what I'm doing here is I'm looking at, and I'm just doing this so that we can see the output, I'm doing this MAD median normal distribution. And that normal distribution, if you're familiar with statistics, that's where B is equal to 1.4826. And of course, for those of you who are familiar with how distribution and the bell curve works, you can go to that and you can see which distribution you're going to assume. We're going to assume in this case it's normal. The other thing here as well is I'm looking at this upper. That's key. It could be lower, right? I could be multiplying it times -3. That would be the lower bound. I'm looking at the upper bound in this case, and because we know the highest value is 30, that's why I'm looking at that upper bound. I'm assuming it's 3. Keep in mind, it's just like with outliers. Sometimes we might assume anywhere from 2 to 3, right? We could say 2.5, we could say 2, etc. But in this case, I'm going to go with the assumption that it's 3 here is going to be the upper bound. And so we'll output that in a second, and we'll see those values, and I'll explain them. And then what we do is we finally filter out these median absolute deviation, median values, and we return the median, right? And it will return a 1 in this case instead of a 2, because what it's going to do is it's going to filter out this, as we'll see, this 11th value, and then it's going to get the median of the 10 values. So let's go ahead and let's execute this. What I'm going to do is, first of all, comment this out, and then we'll go back and we'll review again the steps. And to keep this within a short time range, I can't go over every single detail, but we are looking at this, and you can get further information about this. Okay, so we get our original median, and we remember that that was going to be 2. Okay, so I'm going to skip that because that's pretty, I think, pretty intuitive. Then we get the median value of this variable table here, okay? And we see that the median absolute deviation median value is 1, right? And that's after we subtract all of that. And we also see that the normal distribution, that makes sense, 1 times 1.4826 is, all of us know that right there, it's going to be that same value, right? And then we multiply this right here, and this is the upper bound, times 4.4478. So we think about what we're going to do here, and I forgot to highlight this a second ago. We are going to filter out every value that is greater than this value right here, which this is inverted, where we see where the value is less than or equal to, which what we're saying is any value that's greater than this value right here that I'm highlighting, any value that's greater than this value has to be removed, right? Why? Because it deviates too much. We don't want that at all, okay? And then we're going to go back and we're going to get that median. This is the final median value, as we see. We're going to get that median of the data set with those values removed, right? And now in this case, it's just one value. It's just that 130 value, but that's something that in a bigger data set, there might be a few. So one example that I've seen this used in is home prices in the United States, especially by area. There's one region in the United States, I believe it's in Wyoming, that have exceptionally high home prices, right? And it's very interesting when you get the median, I think it's Wyoming in general, the median home price in Wyoming, and you filter that out, right? And you get the median home price with it filtered in. So that's an example of where this would be useful in application. Another one in terms of this year involves COVID, of course. And one of the things that we know with COVID is just the other factors with that. Now, of course, granted, I live in the U.S., so this is kind of a U.S. context here. But what's interesting, and I was able to get access to a data set on this, and no, I'm not discussing the detailed information, but I will say that I was looking at both sides. So remember up here, if we go up here, I'm multiplying this times basically a positive 3. Well, what if I wanted to look at other risk factors with COVID? So for instance, let's suppose somebody has cancer and they have COVID. Or let's suppose somebody has nothing wrong with them at all. They're perfectly healthy, right? They have good magnesium levels, they have good vitamin D levels, they have good fitness levels, etc. That would be on the other side, right? That would be the other side of that extreme. And then the other extreme would be they have like thousands of factors wrong with them, right? And so what I want to do is filter that out and then take the median of how many, let's say, risk factors along with it and the probability of death or so on and so forth. And so that's an example this year of looking at data. But for the most part, I would say with like incomes and houses. Well, incomes in general is useful, but houses in specific areas where you have those exceptionally high values. So again, there's a lot more that you can dig into. I would definitely look at more information for this because depending on what data set you're looking at, you can't assume normal distribution, number one. And then the other thing as well is for your data set, you might actually want to use a stricter filter. Now be careful because as you see when we look at this, if I had used a lower number, like I could not have used 1, that would have filtered out all the 2s, right? So if I had used too low of a number, I might have bumped out some values. So we just want to be very careful about using too low of a value. And the same applies to as well when it comes to the standard deviation with average. We want to be careful about how low of an outlier definition we're using on the standard deviation. That could really impact how many outliers we end up eliminating.